Hi, I'm Jingwei from National University of Singapore. It's my pleasure to share our research. It's a joint work with Zhao, Wang, and Wang. The general problem we study is conditional sequence generation. We have a sequence input and a sequence output. Here we assume there underlies a style factor sequence, which can render the conditional content and recover the observational output. To realize this idea, we need a style prior, which models the style distribution given the conditional content. And we also need an autoencoder to disentangle the style from the content and to reconstruct the output based on the given style. In this paper, we study style prior modeling through the task of accompaniment arrangement. We consider a piano accompaniment score as input, and we aim to generate a corresponding multi-track arrangement for the whole piece of music. In this case, the style factors mainly regard the long-term flow of the multi-track form. This is how we implement this idea. Let xt be a 2-bar segment from a multi-track music score. We represent each track as a 2D piano roll-like matrix, where superscript k indicates parallel tracks. We downmix all music notes and derive a content feature, which we call piano reduction. And we marginalize the pitch dimension within each track and derive a style feature, which we call orchestral function. Our autoencoder works as follows. We encode the style representation from the orchestral function of individual tracks. And we encode the content representation from the piano reduction. On top of that, we have a decoding module reconstructing each track, leveraging the style cues from corresponding orchestral functions. To acquire the long-term flow of orchestral function style, we model the conditional style distribution given the content sequence. We have an encoding module based on transformer encoder. It captures the global context from the conditional content sequence. And we have a decoding module featuring interleaved transformer layers. Such an architecture allows us to model 2 dimensions, namely track and time, more efficiently. We also apply varied positional encodings to help with model optimization. So to this end, we've introduced our technique details for piano to multi-track arrangement, where we leverage an orchestra function prior for whole song multi-track modeling. Actually, we can reach more than that. The same methodology applies to lead sheet to piano arrangement as well, this time using a piano texture prior. By stacking both stages, we come to a complete music automation system from lead sheet via piano to multi-track arrangement. The style factors on both stages are controllable. Here we have an example showing how the system works. The test piece here has a length of 60 bars, and we can arrange for the complete whole song. We show the final arrangement score for the 2 chorus parts from bar 13 and bar 41. Let's listen to the first chorus. And third chorus. Here we can see coherent texture patterns over the extended context. While the latter chorus part has an extra piano arpeggio to mark the music development. We also see some other favorable features that are commonly seen in composition practice. We have more detailed analysis in our paper. Thank you for your attention. For more details of our work, please see our paper, demo, and code.